Good morning, everyone, and welcome back to projectCD.Chronicles. Let's go ahead and launch this program, which you can find on MOS Commando Marco Bergomi, where I have combined some internal routines by Felice Nardella. It's not actually a remake of this program presented on the official Facebook page, but let's say I have adapted some parts of it to 64 programming and only made very minor modifications. In this brief introduction to the game, we will analyze its various features, some of the unique aspects that have been implemented, and more. If you're interested in game programming, especially for the Commodore 64, stay with me until the end of the video. All right, this is obviously the final video. Let's get back, however, to the two reference groups that I follow. First of all, I want to clarify that the original project can be found in MOS Commando by Marco Bergomi, who has provided a thorough description of it. This is the original. I have taken part of this program and worked on it. I had just made a few, let's say, sprites for explosions, really not much, but let's say I also implemented, still in this part, some interesting features in my opinion, such as getting the keys from the CIA. I consider this project, which will actually be the subject of a version 2.0 video, still on this kind of game programming, because due to time constraints, I wasn't able to complete everything. But let's say I implemented a feature that Felice Nardella had shown us, which you can see was the Tremors, or what is called the video scrolling through a particular register, a specific technique. Now, I truly believe that these particular projects are highly instructive and provide us with a truly complete and comprehensive product, as well as offering valuable insight into the intricate way of programming. As you can see, this is the translation as far as the 64 task is concerned. Here I created a batch, but it's very simple. I just reproduced intent. We are going to see in action some of the techniques that were used in order to produce this game. In my opinion, it's a small milestone in programming because it lays the groundwork for what will become real game programming. It truly has everything. Of course, the game itself can then be expanded with improvements such as sounds, sound effects, introduction screens, and so on. But I find it particularly instructive, and of course always refer to these groups where you will also find both the source code and the program. And then we will definitely come back to this other part by Felice Nardella about sprite multiplexers, because it's something I would have liked and should have implemented as well, for the Osiris demons, but due to time constraints I wasn't able to. Let's say this is video 1 of 2, and later on there will be a second video 2 of 2 on the channel. And this of course is the program I just showed you, which obviously ends, and we can run it again if we want. As you can see, this is the presentation screen, and basically it takes what is. So here we need to take 2 steps, and this is a bit of a description. So first I created a bitmap image, and then using a PETSCI converter program, which you can easily find online, I converted it into PETSCI characters, as you can see on the screen. And I liked this more than a graphic presentation, precisely because of this flickering effect on the screen, which is illustrated in Computing Italia by Felice Nardella using a small basic program. In fact, we'll take a look at it right away because it's towards the end. So let's take a look now. Let's go find it. Let's get back to us. Thanks to the magic of video editing, we've jumped straight to what is the Tremors routine. Felice presented us with this basic program where he uses a particular register of the Commodore 64, and here we see it in action. Let's take a look right away. It allows you to perform certain operations on the Commodore. In particular, let's say here, though it's not exactly completed, selects multicolor mode, chooses the screen mode between 38 or 40 columns, and performs a horizontal raster scroll. But watch out, because here I've selected an additional part that, in my opinion, is a bit more complete, and I'll show it to you. What interests us are the various bits that are used, particularly bits 3 and 5, and this, as shown in other videos as well, allows you by setting these bits to basically set a value for horizontal scrolling. Now, if these weren't present, the characters would basically be shifted by 8 pixels at a time. However, we can manage the number of pixels that can actually be shifted through this register, and we can tell it to shift a certain number of registers at a time. Obviously, this program is much more readable than its assembler counterpart, which so to speak, I had, let's say, translated, and which I will post in the group today anyway. So at least I can share the same code. And all it does is create this effect through two loop iterations, as you can see, a bit to the right, a bit to the left, and they produce this flickering effect. Basically, the routine itself, which I call Tremors named after an 80s movie that, of course, not everyone has seen, does nothing more than use the color register. And by making the right adjustments to this register, it manages to create a horizontal scrolling effect, moving a bit forward and a bit backward, effectively simulating this kind of effect. By the way, I'll make it available, and that's about it, really. This particular routine, by the way, while in the original program it was specifically called through a repeated goto statement, here we actually find it being called quite effectively within a continuous loop. Because now we are going to look at it from a technical perspective, examining in detail how what is essential actually all the fundamental phases and intricate components of what truly makes up a comprehensive game engine are meticulously put together and integrated into a cohesive whole. So through this loop, it keeps repeating this part, and that's what creates the scrolling effect, you see? I'm basically waiting for a key to be pressed through this subroutine. If no key is pressed, of course, it just keeps going, but this is the final part. You see here, there's this part I wanted to show you. This is the game loop, the start screen, and it runs exactly this section. But actually, once you have access to the source code, which I'll be releasing, it's much easier to look through it than, of course, trying to follow along in a short YouTube video with just a few lines. The only interesting part concerns what is screen 2, but it's exactly this section that has basically been translated into ASCII characters. All it does essentially in the start screen routine is perform a simple iteration, and as you can see, copies the pointers from one place to another in what is the screen. Here, clearly the number 4 is used, but it's very intuitive because the registers are limited to 256 bytes, so 8,000, and they are repeated exactly 4 times. So in reality, there's nothing else going on here. By the way, this same part that I showed you, as you can see here, has both a section related to the screen and a section related to the colors, which are then, so to speak, and here we can see displayed on the screen. It's also possible to change the color and do many other little, let's call them special effects tricks. Here really it's the color of the background and the backdrop and so on. But let's look at the main loop of the program, which was designed by Marco Bergomi. I found this type of approach very interesting because it really allows me to understand all the various phases. And you can find it here, as I mentioned, in this version where an update was made, the Osiris 2 daemons. You can see here we are already in what is the second part where now it gets hit. Clearly, there's a decrement of all the various positions. Here, the game loop is managed in two different phases. And pay attention towards the end of the video, and we'll go into this in more detail. We'll be taking the keys directly from CA2 and CA1, but this is a particular technique. Q will clearly handle this end part. All right, let's get back to us. This is the main loop. What happens in the main loop? Obviously, we've already seen the start screen. Then there was a further implementation. Of course, we have the set IRQ. Why did I do this? Because from a logical point of view, this is a part that overlaps with Marco Bergomi's original code, and I'll show you right away by running the program again. Now I'll close it and restart it. Let's pause the video for a moment. All right, let's start it up again. Why is that? Because obviously, as you can see, once I press the spacebar, which I can also do with the joystick at this point, you see that the projectile basically keeps moving along its path. But from a logical point of view, I'm actually no longer controlling through the actual programming what for itself the trajectory of the projectile. However, it is crucial to exercise caution. By meticulously setting the specific values within my dedicated IRQ setup routine, I am effectively utilizing what is commonly referred to as an IRQ loop. Consequently, each and every time this process occurs, all I am truly accomplishing is the invocation of what is, in essence, a fundamental game loop. And what does this game loop do? The game loop basically, as we've seen, does very few things. Oh dear. It will start by checking which keys are pressed. So we will check player input for the keyboard, check player input for the joystick, and also handle the movement of Osiris, which is the spaceship, as you can see, is the one that falls from top to bottom because it gets hit and then the fire part, as I'm telling you right now. But here, we need to search for it as a whole word in the routine, okay? So basically, I no longer have to worry about creating a suitable loop, but when it detects through a flag that the fire button has been pressed, it will automatically increment the projectile, and this projectile will move upward, or if it gets destroyed, if another projectile is created. This is a management approach that in the end has both simplified and, how can I say, complicated things at the same time, at least initially when it came to handling this. Well, that's absolutely everything that precisely happens within the intricate game loop as far as the entire comprehensive raster line is concerned. So the interrupt, so every single time I've meticulously extracted a game loop that effectively handles movements as if they were distinct and separate events, right? And this happens with the movement of the various keyboard inputs, with the movement of the joystick, and with the control and updates regarding the various, now let's launch it here, the various screens. So every time it triggers, that's when this entire part of the game loop managed by the raster automatically takes over. So I no longer have to basically handle it from a logic standpoint, but every time it's managed by flags, it goes on to increment this whole part. And in the game loop, as I was saying, we have, let's first take a look at the Osiris movement, where we can also set different types of speed. And you can see that it's really nothing more than a simple increment, no longer a loop, because each time it calls this routine for the spaceship's movement. Obviously, here though, I've been knocked out twice. As you can see, it's the movement that's doing it. And this is simply because I wanted to later introduce something like levels. So as we increase the levels, the simplest level will have an increment of 1, a more complex level will have an increment of 3, and an even more difficult level will have an increment, let's say, of 5. Now, still regarding the game loop from the perspective of the raster, and then we'll return to the last part about sprites. Here we have what I consider to be two important routines. One is essentially the joystick management, and here I simply reused a series of routines that I had actually already used for key pressed handling, because that's a bit more the focus of what I had done. It's exactly the same as the code written by Marco Bergomi, nothing particularly different. Uh, all the part, let's say, regarding the definitions was done beforehand. So in the future, even if you want to make individual changes, for example, you just need to change one or two lines of code here, like minimum or maximum values or whatever, to achieve a more substantial and definitive effect. And that's definitely something within the program. Another bit of video editing magic. Let's get back to the IRCO loop. As we know, we need to return with the 831, but that's not always the case. In certain situations, and maybe we'll cover this in a more advanced video, you might need to return with the 81. Let's go back once again to our game loop search for game loop, because I wanted to show you this additional technique, which is specifically identified by the check player input function that does it through the keyboard, and it's right here. So here I've used a particular technique. First, I could have done it with register 197, and specifically with register 198, I would have had to initially clear the buffer. Now there's a small problem, because firstly, from an analog or continuous pressing perspective, only the arrow keys and maybe the space bar, if I remember correctly, allow for repeated input. On the other hand, the A key, the D key, or any other key clearly do not allow for repetition. There is a specific location to set up key repetition. I could have done that as well, of course, but I ended up finding a much more complex solution for this. Let's go to C64 OS, and here I'll leave it attached for you because there is a whole description specifically about using the keyboard through CO1 and CO2. In particular, here we refer to the pinout. And if you take a look at the keyboard here, there's actually an electrical circuit. But okay, this is the image I wanted to show you. If you take a look at the keyboard here from the Commodore, it's organized exactly like a grid with rows and columns, you see? So we have row 2, the Q key, and then it's used in various columns. And in this video, maybe we'll also zoom in because my image will be here. You see the keys are mapped at the circuit level exactly to what are basically the keys themselves. And here on C64 OS, the original author of the article also shows us the logical mapping, where basically he says that given an electrical impulse, the row and column are identified in order to determine the exact position of the key. Let's get back to our topic. And here clearly is the slightly more complex part, because I basically have to provide certain information to what are CO1 and CO2 so that they can write a specific value or read another one. In particular, as you can see here, I have to write the column, retrieve the row, and then perform an AND operation on the position itself as a reference. And here we return once again to our table of these keys. Clearly, the management is definitely more complex, but in practice, it allows me greater control over it, and also enables truly analog use without any issues and without any further intervention. Well, obviously, let's get back to our topic. Clearly, this part refers undoubtedly to two registers, DC0 and DC1, which identify both the joystick reading ports, but be careful, they also identify the reading of what are, as you can see here, and I'll enlarge it for you, the matrix columns. And clearly the routine here is explained because through this I write to the register at the position of these bits and tell it which column is active. In particular, if I take this further part with the end, once I have the active column, I determine which row is active. And obviously, if it results in a 0, that's how the key pressed is identified. And then here, it's really very easy because I have A, D that I write, and basically Q, but these have actually been remapped into everything that is the joystick part without any other issues. And this is the slightly more complex part that has already been implemented. Getting back to us, obviously in the description of our program, we have the execution of the start screen, the starting screen that you saw. We have the setup of IRQs, the interrupts as I already mentioned earlier, in order to check every time I press the fire button in particular. So there will be another routine. You can see this as a kind of thread. Here, a setup of the screen is done, but as far as drawing the arena is concerned, the initial counters are reset, as well as lives, energy, and so on. We have a whole part for setting up sprites, which we can also take a look at. And then these are routines where the daemon is placed. A random function RND is used to change the daemon's horizontal position, and these further routines are used for what is basically the updating and the update of the data. Basically here, as a final part, and in fact, I notice a peculiarity. This is actually done outside of the raster routine for certain reasons, and maybe the more experienced among you could tell me why. Because within the raster, this type of routine has some difficulties and basically only detects the collision of the first element, but not the others. This is probably because when we program the raster, we have to stay within certain parameters, timing constraints, and so on. The only real drawback, or rather the only inconvenience in this main loop, is that collisions are managed outside of it to allow checking all the various collisions. As you can see, the various collisions, this is the sprite here identified between the different sprites. If the missile meets the ship, the missile with what is the spaceship Osiris, which is the demon. Then there's also a final part, which is the explosion of the ship. Marco basically showed us this as a change of loop, where this is done with a slightly longer duration to allow us to visually see the explosion, decrement the life, update the screen, and a whole series of, as we can see here from the code, and we can see it in the retrocollite, where it actually handles the animation itself of the explosion. Here we can still do round. So this is the demo. It's exactly this part where it handles the animation of the explosion itself. After that, well, the daemon is reset, and of course it goes on to display the end at the end. The best part for sure, and we'll end the video here, is the break instruction, where it ends the execution of the program itself, returns to the part. Is worth noting that you can find this break instruction here and only here, but I've never found it anywhere else in the entire ROM as far as the Commodore 64 is concerned. Well, what else can I say? Let's run the program one more time. What can I say? This is a brief overview of game programs, and we'll come back to explore this part further depending on the comment. I'll also try to translate this part into English for anyone who's interested. And what else? I'll publish this in Italian, and then I'll publish the English parts later on, time permitting. Well, what can I say? Thank you all for sticking with me up to this point, and I'll see you soon here on the channel with the next video. Thank you all.